this is our initial pressure, which is 1.5. So we have to identify the pressure, and we have the initial dryness fraction, which is 0.8, and we have the final pressure after throttling is what? It is 0.12, and it will be equals to 1.2 bar. So let's take a look and see the 15 bar. Where's 6, 15, 15, 15? So this is 15. At 15 bar, the value of the H of F will be 845, and also the value of this, which is the H of Fg, will now be what? Will now be 1947. And also, so as you can see, you have to take note of the value of H of F, and also what? And also the value of H of Fg. So therefore, let's write the values down and continue to the solution. And continue with our solution. So let's take a look and see the 15 bar. Where's 6, 15, 15, 15? So this is 15. At 15 bar, the value of the H of F will be 845, and also the value of this, which is the H of Fg, will now be what? Will now be 1947. And also, so as you can see, you have to take note of the value of H of F, and also what? And also the value of H of Fg. So therefore, let's write the values down and continue to the solution. And continue with our solution. So, since the throttling is an isenthalpic process, H1 must be equals to what? Must be equals to H2. So, I'm first going to find the initial enthalpy from the steam table at 15 bar, because this 1.5 will now become what? Will now become 15 bar. So I'll have the pressure after converting it, which is 15 bar. You have to take note of that. Some of the pressure are in kilonewton per meter square, some are in mn power per meter square. So you have to take note of the conversion. So this 1.5 should now change to 15 bar. So from the steam table, we are going to find the H of F, and also we are going to find the H of Fg. So let's take the steam table and see. Where's 6, 15, 15, 15? So this is 15. At 15 bar, the value of the H of F will be 845, and also the value of this, which is the H of Fg, will now be what? Will now be 1947. And also, so as you can see, you have to take note of the value of H of F, and also what? And also the value of H of Fg. So therefore, let's write the values down and continue to the solution. So as you can see, the H of F, it is what? It is 845 from the steam table, and also this is 1940 what? 1947. So since our dryness fraction, it is what? X1, it is 0.8. So therefore, I will say X1, it is 0.8 here. So the next thing I will say, my H1 should now be equals to, I will have the H of F plus what? Plus XF plus X1. Yes, X1 H of what? H of Fg. So this will now be equals to our H of F, which is 845, and therefore plus the dryness fraction. So I will say 0.8 multiplied by the H of Fg, which is what? Which is the 1947. At the end, let me see what should I going to get. So at the end, I will get 2402 point what? 0.6 kilojoule per watt per kg. So, and therefore H2 also will now be the same thing, which is 2402.6 watt kilojoule per watt per kg. So the next thing that I'm going to do here is that I have to next find the dryness fraction after what? The dryness fraction after throttling. So let me do like this. Let me say the dryness fraction after throttling, but I'm going to find the I'm going to find my h of f and h of fg at what? At 1.2 bar, because this 0.12 bar, after converting it, it will now become 1.2 bar. So I'll find in what? 1.2 bar. So I'll check my steam table under 1.2 bar. And what shall I going to get as my h of fg, which is the enthalpy. So let me check for h of f and h of fg. So also for 1.2 bar, as you can see, also for the 1.2 bar, as you can see, this is 1.2 bar. So I'll first take a look. This is my 1.2 bar, and this is h of what? H of f. So I'll come across to the third line. So the h of f will be 439, and therefore the h of fg will be 2244. So also I'll pick those values, h of f and also the h of what? H of fg, which is 224. So as you can see, h of f, it is what? It is 439 kilojoule per hour per kg, and the h of fg, it is what? It is 2244. And the next thing that I'm going to do, I have to say the h2, it should now be equals to what? The h of f plus what? Plus the x2 h of what? H of fg. So you have to take note that I already have h2, because I say this h1, I said h1, it is equals to what? It is equals to h2, because since the throttling is an isenthalpic process. So I'm looking for x2 now. I'm going to find this dryness, so I need some space. So I'll now say what will be my h2. Okay, sorry, I delete it, but it is what? It is 2402.5. it is equals to what? It is equals to 439, which is the h of f, and plus what? Plus x2, because I'm looking forward for the x2 multiplied by h of fg, which is this, which is the change in h of fg. It means hg minus what? Minus hf. So which is, let me open the bracket and I will say 2244. So the next thing that I'm going to do here is that I'll keep my 2402.5, and therefore this 439 will now cross the equal sign and it will become negative. So I'll have 439. So therefore this will now be equals to, and again I'll say if I multiply this and this, I'll get 2244x2. So I'll subtract this. If I subtract this, I'll get, oh, I should just divide both sides by what? By 2244, because I'm looking forward. I'm looking for x2, 2244. This will go with this. At the end, x2 will now be equals to 2402.5 minus 439. Divide it by 2244. So what should I going to get? So this should now be equals to x2 will be 0.875. So this is my x2. We are to determine the dryness fraction of steam after throttling. So I will now say therefore x2, it is 0.875 after throttling. So this is the end of what? Of this question. A boiler device produces a steam of 2 mn per meter square at the rate of 2 kg per second, and temperature of 300 degrees Celsius is throttled to a pressure of 800 kilonewton per meter square. It then makes a what? It is then makes a steam at pressure of 800 newton per meter square, which at 0.9 dryness flowing at what? At the rate of 5 kg per second. So we are to determine the condition of what? Of the resulting steam mixture, and also we are to find the internal diameter of what? Of a pipe convey the steam at what? At 2 mn per meter square if the velocity is what? Is the steam is limited to 15 meters per second. So the first thing that I'm going to do is that I'm going to use two steam. The first steam, which is this 2 mn per meter square, I'm going to convert it. It will now become 20 bar. So you have to take note of that. Let me call this what? Steam what? Steam 1. At the pressure at what? At 20 bar. At 20 bar after conversion. And you all know that the mass flow rate, which is what? Which is 2 kg. And I have my T1, the temperature, which is what? 300 degrees Celsius. And therefore, it is throttled to what? To 800 kilonewton per meter squared. This pressure shall now change and it will become 8 bar. So therefore, I will now say at steam 2. At steam 2, at what? At 8 bar. 8 bar, because this is in kilonewton per meter square, so the conversion will not be the same as this in mn per watt per meter square. So this is what? This is 8 bar, which is the second steam. And therefore my dryness, which is x2, it will now be 0.9. And therefore the next thing, which is the mass flow rate 2, it is what? It is 5. This is 5 what? 5 kg per second. So first condition, I'm to determine the condition of the resulting steam mixture. So I will say the condition of resulting mixture at 20 and at what? Sorry, at 20 bar and this 30 degree Celsius of the temperature. So I'll find what? I'll find my H1. So as you can see, I'm going through directly to a superheated steam table. So if I check out, let's check the steam table, the superheated steam table, and see 20 bar at 300 degree. Let's see what we are going to get. So as you can see, here is a superheated steam. So as you can see, this is what? This is superheated what? Steam. At the superheated steam, it says the condition of the resulting steam mixture at what? At 20 bar. So I'll look for 20. So this is 20 bar. And therefore, I'll look for 300 degrees Celsius. So this is 300. So I'll come across 300, 300, 300. And then I'll say, what will be my H? My H will be what? Will be 3000 and what? And 25, which is 3025. So I'm going to write the what? The value, which is 3025. So as you can see, this is how you can find the superheated. You come over what? Over the superheated steam, not what? Not a normal steam table. So you are going to look for what? For the superheated, and the superheated, it also has its own values. So you have to take a look for the temperature and also mark what? Mark the pressure, and also find what? Find the value of what? Of your H. So as we can see, we find the value of our H, which is 3025. So then we have to write it down. As you can see, from what we check, we got H1 as 325 what? Kilojoule per watt per kg. Since the throttling is what? Is isenthalpic. So I will now say my H1 will be this, and therefore at 8 bar, at this 8 bar, I have to find my temperature and Hg. So let's check and find our temperature and also our Hg. So let's see this at what? At 8 bar. So at 8 bar, we have to take a look to 8. Yes, we are having 8. And we are looking for temperature. So let's check the temperature. The temperature at 8 bar is what? Is 170.4. So you have to take note of it because I'm going to write it. And also I'm going to take a look to my Hg, which is 2769, which is the same thing as 277 what? 0. So therefore I'm going to take note of what? Of this. Because from the questions, we are going to find the steam table at what? At 8 bar. We are going to find the Hg, and also we are going to what? We are going to find the value of what? The value of our temperature. Yes, as what we see from the steam table, we have 770 kilojoule per kg, and therefore our temperature is what? Is 170.4. So the next thing that I am going to tell you is that since this 3025, this H1, it is what? It is greater than this temperature in degrees Celsius, which is, okay, sorry, it is greater than what? It is greater than the, okay, I'm sorry, the temperature is, this supposed to be, is the temperature 170. Temperature, it is 170.4, and Hg, it is 2770. So now, since this H1, it is greater than Hg, which is 2770. So steam 1 remains superheated after throttling from what? From the superheated steam table at what? At 80 bar, which is the temperature, which is what? Which is 300 degrees Celsius. I hope you get it. I just said, since this it is greater than this 3025, it is greater than this 2770. So steam 1 will remain what? Will remain superheated. So this steam 1 remains superheated after throttling from what? From that superheated of what? Of this 8 what? Of this 8 bar. So therefore the T now should now be what? Should now be 300 what? Degrees Celsius, as we all know. So from steam 2 at 8 bar, I have to find of F at what? At steam 2 at 8 bar, and therefore I have to find H of F what? H of Fg. And also I know my X, which is 0.9. So let's check and see. And then also the H of F, let's see the H of F. H of F is also 721. You have to take note of it. And also the H of F of G, it is also 248, which is 2048. And also the Hg, it's 2770 or 276 what? 69. So you have to take note of all this. So from now on, I will say H2, it will now be equals to H. The formula says H, which is equals to HF plus what? Plus X, which is HF of what? Of G. So this is my HF. So I'll insert it. So it will now become 721. And therefore I have to say plus my X, which is 0. What? Which is 0.9. And I'll multiply with this H of Fg, which is what? Which is 24 what? 48. So at the end, I will have what? Let me see what should I going to get in total. 721 plus 0.9 multiplied by 2048. So I'll get 256 point. Okay, I have 4.2 kilojoule per kg. So I already find the value of what? H2. So this is what? This is H2. So the next thing that I'm going to do here is that the reason why I say it's H2 because I use the second steam table, and therefore I use the second dryness fraction, because the dryness fraction that I'm giving, it is only the second, which is at what? At steam 2. So as you can see, our H of F, it is what? It is 721 kilojoule per kg, and we have 204.48 as our what? As our H of Fg. So I'm going to calculate H2. So to calculate H2, I'm going to use this HF, and therefore I'm going to use this. So let me have some space. So now the next thing to do is that I'm going to apply the energy balance, which is, I would say, my total mass should now be equals to the total mass. It is what? I have two masses. I have 2 plus what? Plus 5. Let me show you. I have this mass 5, and I have this 2 and another mass. So the mass in total will be 7 kg per second. So I will say the total enthalpies. What will be my total enthalpies? The total enthalpies now should now be, I will say, 2 multiplied by the enthalpies that I find, which is H of Fg from the first steam, which is 302.25. Then I will say plus what? plus the 5. I'm multiplying the masses. I use the first mass to multiply by the first enthalpy, and I use the second mass to multiply by the second enthalpy. So I will say multiply by the enthalpy that I find, which is what? Which is 2, 5, 6, 4. This is the enthalpy. So therefore, but as you can see from the last, our enthalpy that we find, it is H1. Sorry, it is not H of F of G, it is H1. Whereby I use the superheated word, the superheated steam table, whereby I find 20 bar at the 30 degree, which is the superheated, and then I find this as my H1. And therefore, this is my what? This is my H2 here that I what? That I find. So therefore, I will say point what? Point 2. So at the end, this will now become, let me see what should I going to get. So therefore, this should now be equals to 18,871 kilojoule per second. At what? My total enthalpy entries. So the next thing that I'm going to do, guys, is that next I'm going to find the specific enthalpy of what? Of mixture, which is H of M. So the specific enthalpy of mixture, I will just say the total enthalpy entries, I'm going to divide it by the total mass. So therefore, I will say my enthalpy, which is what? 18,871. I have to divide it by the total mass, which is 7. So at the end, I will get 2695.8 what? Kilojoule per kg. So the next thing that I'm going to do here now is that I have to determine state of what? State of mixture. I'm going to determine my state of mixture. And you have to take note, my H of F, it is what? It is 721 at what? At the second steam, 721. And therefore, my H of F of G, it is 2048. But you have to take note at 8 bar. So now, since the 721, which is the H of F, it is greater than what? It is greater than this specific enthalpy of what? Of mixture. And therefore, it is also greater than, let me have some space. What I mean here is that I say, since this 721, it is what? It is less than HM, which is what? Which is the specific enthalpy of mixture, and also it is less than 2770. So therefore, the mixture is what? Is wet steam. So I will say this mixture is now wet what? Wet steam. So therefore, I will now focus on what? On my dryness fraction. So I will say this dryness fraction will now be equals to the H of M minus the H of F, and also I will divide it by the H of what? H of the FG. So this should now be equals to the H of M, which is what? Which is 2, 6. Okay, let me have some space. I need to have space so that I'll proceed. So this will now be equals to, I will now say I'll have 2695.8 as my HM that I already find. I will subtract it by the HF, which is 721. I will divide it by H of FG, which is 2040 what? 2048. So therefore, at the end, my dryness fraction will now be 0.964. So at the end, my result of this question, of this condition that I'm going to, of this condition of the resulting steam mixture, so I will now say the X, let me say my X will now be 0.96 what? 64. Because the question asks, determine the condition of the resulting steam mixture. So therefore, this is the end of what? This is the end of this question. And therefore, the mixture, it is what? It is wet steam, as I explained it what? Before. So let's move to II2. So therefore, from the second question, we are to determine the internal diameter of the pipe to convey the steam at 2 mn per meter square if the velocity of the steam is limited to what? To 15 meter per second. So the first thing that I have to find the total flow rate. What will be my total flow rate? The total flow rate, which is this, it is the same thing as V, which will be equals to the V of F plus what? X, which is Vg minus what? Minus Vf. So I'll currently check to my steam what? Steam 2, which is at 8 bar. So the specific volume of the mixture at what? At 8 bar will now be what? I'll find the F of B of G, and I'll find the B of F and what? And B of G. So what will be my B of F and B of G? You have to take note that B of F, I am going to what? Okay, let me check the steam table. So at this stage, I'm looking for BG at 8 bar. So I'll first take a look to this. Where is my 8? So this is my 8. And I'm looking for BG and what? VG and BF. So this is VG. I'll come across this, which is 0.2403. So I will just write my value of what? Of VG, which is 0.2403. So since I didn't have my B of F, so I'm going to use 0.0011 meter cube per watt per kg in order to find what? In order to find my specific volume. And then I'm only looking for VG and what? And VF, or B of FG. So whenever if I find the value of B of F and B of G, so I will be able to find the value of B of what? B of FG. So you have to take note, this is the value of what? Of VG, and therefore I'm going to use the constant of 0.0011 meter cube as what? As my BF. So you have to take note of this. Yes, as I said, 0.010011, it is what? It is a constant, so therefore I'm going to use this constant. And from the steam table, our VG, it is 0.2403 what? 3 meter cube per kg. And our dryness fraction, as we are given, okay, let me check. We find our X what? Our dryness fraction 2, which is 0. Our X2, I think it is 0.964. Yes, it is 0.964. So therefore we are going to use it. So as usual, I'll now say the total flow rate, the flow rate, it will now be equal to, our substitute. I'll have 0.0011. Then I'm going to say plus 0.964 multiplied by, I will say VG minus BF. So VG, which is 0.2403, and I will say minus 0.0011. This is 0. So at the end, the flow rate will now be equals to 0.232 meter cube per kg. Yes. So the next thing is that I'm going to find the volume flow rate. This is the total flow rate, and then I'm going to find the volume flow rate. So therefore this is very easy. I'll say multiply by what? By MB, and this is the same thing as 7, which is our mass, our total mass, which is what? Which is 7, and therefore I'll say multiply by the volume. I am given the volume. Yes, I find it, which is 0. Which is the total flow rate? 0.232. So this will now be equals to 1.6 what? 624 meter cube per second. And you have to take note that the question says the internal diameter of the 5 conveyor at this. So if the velocity of what of the steam is 15 meter per second, it means we are given the velocity of 15 meter per second. So maybe the question, it is showing me that I can be able to find my area, or let me see diameter. So let me have some space. So now I will say, given the velocity as what as 15 meter per second, A, it is equals to me the Q over what over V. So this will now be equals to 1.624 divided by what by 15, and therefore my area will now be 0.1083 meter squared. And therefore, what should I go into say? I will say area, it is the same thing as what? As pi what? Pi. Okay, let me have some space because I don't want to confuse you. So I will say my area, it is the same thing as pi what? Pi d square over what? Over 4. So this is my area. Area, it is the same thing as pi what? Pi d square over 4. So I'll cross multiply and I'll have A4 or 4A. But I'm supposed to say 4A. It will now be equals to, this is the same thing as over 1. So I'll only have pi d square. So next, I'm looking for d. So I have to divide both sides by pi. Divide both sides by pi. Pi will go with pi. So d square will now be equals to 4a by what? By pi. After then, I will say taking the square root of both sides. This will go with this. At the end, my d will now be equals to 4 multiplied by a divided by what? By pi, which is equals to all inside root. So I will have 4 multiplied by 0.1083 by pi, 22 over 7. So what should I going to get approximately? So my diameter, it is equals to 0.371 what?